Yeah. Okay, so number 3, I'm just going to draw a picture because you can read the question. So it says there's a 10-foot ladder and it's leaning against a building, right? And the bottom of the ladder is 2 feet away from the building, right? So the bottom side is 2 feet long. It's not really the ladder, it's like the ground under the ladder. It's 2 feet long. Then the building goes straight up and you have to find out how tall it is. So do you see they even have a picture of it. So the picture is kind of cut off there. Sort of too bad. So do you remember the Pythagorean theorem? That's the one that that guy would throw you over the rowboat into the lake if you told anybody his secrets. So a squared plus b squared equals c squared, like that, right? So 2 squared is 4. Now what are we finding? Trying to find out how high up the building it is. What? I almost feel like this problem is too easy. You think this is too easy? 2 squared. Well, the thing is, I remember a problem like this on the final before, but I think it was a little harder than this. It was like the bottom of the building is 2 feet longer than the height of the ladder. So the bottom was like 2 plus x, and then the ladder itself was like x. But I'm just going to do the one that we have right here, though. So 2 squared is like 4 plus x squared equals 100. Subtract 4. Well, now it's getting hard because now you have the square root of 90. Now you have 96, right? So how do you find x? You have to take the square root of 96. So x equals the square root of 96. Now, technically, it's positive and negative square root of 96, but you can't have the ladder can't be negative high. So it has to be positive. And then can you break down the square root of 96 in any way at all? 4 times 24, would that work? So if I could break apart the square root of 96 into 4 and 24, and then the square root of 4 is equal to 2, right? Wait a second, no, sorry, my fault. Actually, there's a bigger number besides 4 that goes into 96, 16. 16 times what? 16 times 60 plus 6, 16 times 6. So actually, you could break it down into the square root of 16 times 6. And then what is the square root of 16? It's 4. So it actually breaks apart into 4 square root of 6. So that's x. So how high does the ladder reach? It's equal to the ladder's whatever that answer is. That's how high it reaches. 4 radical 6. Okay, there we go. Perfect. Maybe it was actually college algebra that I was remembering that had a little bit harder of a problem like this. I think it was. So in intermediate algebra, it's kind of simple, except for the square root of 96. That's actually pretty advanced. So make sure you know how to break down the square root of 96 or whatever to be smaller than that. Then let's do number 4. If you're ready. Are you ready? All right. So number 4. It says x minus 7 to the second power equals negative 49. And it says solve it with the square root property. So that square root property says that if you have anything squared, that the value that is inside of the square is equal to positive or negative of the square root of the value that's on the other side. So x minus 7 is inside the square, and that's equal to plus or minus the square root of the other side. Does that make sense? So we've done the square root property before, but then this is a sort of a test of your knowledge in chapter 8. What do you get if you took a square root of a negative number? It's the same as if it had been positive, except for what? So it's going to be like plus or minus 7, except what do you have to put beside the 7? I, right. Good job. X minus 7 equals that. And then you have to move this 7 over, which changes it to positive 7. So the answer would be positive 7 plus or minus 7i. And then on the computer, you would have to write your answer like this: 7 plus 7i and 7 minus 7i. But since this is a real test and I'm not a computer, you can write both of your answers at once like that, and that's fine with me. So you can just say 7 plus or minus 7i. All right, let's do number 5, but you have to go to the top right corner to see number 5. So number 5 says square root of 11 over x. We have to rationalize the denominator. So first of all, let's separate the top square root on its own and the bottom square root on its own. So the whole square root of 11 over x is equal to the square root of 11 over the square root of x. But then you can't really do the square root of x exactly. So we're going to multiply by another square root of x on both the bottom and therefore also on the top. So on the top, the square root of 11 times the square root of x, they join together and it's the square root of 11x. But on the bottom, 2 square roots of x joined together just equal a single x. And that's assuming that x is positive. If x isn't positive, you'd have to put absolute values around it. But it says specifically assume that it's positive. So this is the final solution. Okay. Now let's do number 6. Square root of 5 plus square root of 2 to the power of 2. So remember, it's a very valuable shortcut, one of the most valuable, I think. When you're squaring a group of two things, you can first apply the square to the first term, which if you square a square root, you'll just get the number in the square root by itself. And then you bring the power down and you put it beside this times this. So you put 2 down here times square root of 2 times square root of 5, like that. Then you apply the power to the last term. So take the power of 2 and apply it to the second square root of 2. And then you'll get just 2 alone, because the square root of 2 to the second power is just what's inside of the square root. And then you combine the like terms 5 and 2, that's 7. And then you combine the two radicals that are both square root radicals. So the square root of 2, square root of 5 is really just the square root of 10. So you combine the numbers and you combine the radicals and you get 7 plus 2 square root of 10. Perfect. Whoops, perfect. Now, number 7. And by the way, this test review is mostly working backwards from the most recent topics to the topics back in chapter 5. So this second in-class test is going to cover chapters 5 through 8. So when you check the actual test, it's going to be in order. So these problems from chapter 8 are probably going to be at the end, and then the other problems will probably be at the beginning. So the review is kind of out of order, but it will be the same problems though, just different numbers in them. So then number 7. This one says 9 square root 80x minus 9 square root 20x. So we can't subtract those two radicals because they're not like terms. However, if I break down the 80 into the biggest it can break down into, which would be, you could break it down into 4 times 20, but that's not big enough. How about 16 times 5? So let's break apart the 80 to be 16 times 5x, and break apart the 20, that can break apart into 4 times 5x. And then this 9 doesn't change, but the square root of 16 is 4, so that can escape outside. And then you still have 5x left inside. And you have minus 9, and then the square root of 4 is 2, and that 2 can escape outside. And then you have 5x like that. So then you have 9 times 4 is 36. And then you still have the square root of 5x. times 2 is 18. Then you have the square root of 5x. So you can factor out the square root of 5x to be at the end by itself. And then the only thing left in front, in parentheses, would be 36 and negative 18. So then what is 36 minus 18? 18, you're right. So it'd be 18 square root of 5x, like that. Perfect. So that's number 7. Wait a second. Did I, hold on. Are there only, I hope I didn't leave off some of these questions. There's only 13 questions on this whole page, right? My email real quick. Or maybe I might have posted this in Moodle in a hidden post. I just want to make sure I'm not leaving out. There it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, guess that's it. Well, I guess we only have 13 questions to review. That's weird. I thought that I picked 4 questions from each chapter. Guess not. Maybe I just fell asleep and dreamed that I did. So anyway, so we're just gonna, so maybe we will get done with class a little bit early, hopefully. So let's do number 8. Number 8. Cube root of 16x to the 4th. By the way, have you ever heard the restaurant ad that says, "Don't be late, we close at 8"? Have you ever heard that one? I wonder if they picked 8 on purpose because it sounds like you ate there. Maybe that would be. So oh, this is John 3:16. 3:16. And then x to the 4th, y to the 2nd times cube root of 4xy to the 18th power. There we go. So how do I do this one? And how do I make this get bigger? Hold on. Well, that's still not big enough. Got to figure out how to make the bottom. There we go. Finally. So number 8. So they're both radicals. What kind of radicals are they? Cube root radicals or square root radicals? They're both cube root radicals. So that means you can go ahead and they're like each other. So you can combine, you can multiply together what's in them. So we would get 16 times 4 is, now actually it might actually make it harder to multiply together right now, but 16 times 4 is 64. Oh, it makes it easier because the cube root of 64 is what? 8. No, I'm sorry, 4. Wait, 4. Yeah. Yeah, the square root of 64 is 4. Yep. Okay, so then x to the 4th times x is x to the 5th. Now you can't do the cube root of that one. So we'll have to break that one down again. But y squared times y to the 18th is y to the 20th, right? You know what? I'm not going to combine those together because you know why not? Because you can do the cube root of y to the 18th already. So you don't want to combine that together because if you can already do it, then you want to leave it alone, right? So we're just going to combine those together like that. And then I can do the cube root of 64, which is 4. You're right about that. And then you have to re-break down the other parts though. Actually, no, the cube root of y to the 18th. What is 18 divided by 3? What is 18 divided by 3? Yep, so the cube root of y to the 18th would be y to the 18 divided by 3, which is equal to 6. So it'll be 4y to the 6th power. But the other parts of it, you can't do the cube root of them as they are. So you'll have to re-break them down somehow. So y squared can't break down into anything that has a 3 that goes into 2. But 5 can break down into you can split up the x to the 5th into being 2 things. X to the 5th can split up into being x to the 2nd and x to the 3rd together, right? And then what's the cube root of x to the 3rd? It's just x to the 1, right? So we're going to give this x to the 3rd goes outside. It's just x to the 1, and then y to the 6. And then the only thing that's still stuck inside is x squared and y squared. So nothing else can come outside. So that's the final answer. Presto. Presto, presto. Have you ever heard of those radio programs where they would play music and you could request songs by calling in? Mm-hmm. One time I think there's one of those programs called Presto Requesto. That sounded weird. And then my brother called up and had them play Happy Birthday Sweet 16 for my sister on her 16th birthday. That was exciting. But they played the wrong version of it and it sounded terrible. It wasn't the one that my sister wanted. Oh yeah, definitely. There we go. Ready? So let's do number 9. So how many lives do cats have? Yep. And that's how I remember which button to push to make the top of the screen go away. It's because I found out it was F9. And then I thought about the cats having 9 lives. Now we have problem number 9, which starts with number 9. 9 over x, it really does, like I'm not even lying, like it's on your page already. Because you have the same page that I have, right? 9 over x plus x over 9, x over 9 plus 9 over x. Oops, sorry. Just kidding. Actually, it would have been easier if that would have been plus 9 over x. Do you know why? Because if this would have been a plus, then this plus this would have been the same as that plus that, right? So the top number would have been the same, and the bottom number would have been the same. If you divide the same thing beside it into each other, you would have gotten 1. So that's too bad. So just because of that little minus sign being a minus instead of a positive, it ruins the whole problem. Except this problem isn't actually very hard though. We have to put parentheses around every single term that we can possibly see on both the top of the big huge fraction and the bottom of the big huge fraction. Then we have to look at not the bottom of the big huge fraction, but the little tiny bottoms of the small fractions. So look at these 4 fractions. What's the common multiple of 9 and x? There'd just be 9 times x, right? So multiply every single thing that I put in the blue parentheses, all 4 of those terms on the top and bottom of the big huge fraction. Multiply each of them beside 9x, like that. 9x, 9x, 9x. Presto. Presto or questo. Then we would actually we would cancel out this 9 into that 9, and cancel out that x into that x, cancel out that 9 into that 9, cancel out that x into that x. So the only thing left is just 9 times 9 on the first, and that's 81, plus x times x, which is x squared, over x times x, which is x squared, minus 9 times 9, which is 81. Amazing. So this is all you have to do. This is the answer. So it seems too easy. Wow. It seems so easy. I didn't actually figure this one out yet, but usually I look back and see if I got the same answer before, but this is correct. So 81 plus x squared over x squared minus 81. Okay, cool. That's it for that one. Now let's try to do number 10. Is it okay if I erase that now? Okay, so number 10. Let me erase this one actually. Is it okay if I erase that one completely? I've been saving it in the temporary storage, but now I'm going to clear that one completely. Okay. So then number 10 says 3x all over x squared minus 49 minus 5 all over x plus 7. Like that. All over. 3x over x squared minus 49 minus 5 over x plus 7. There we go. Then we have to find the common multiple of the two denominators. So if the problem is that denominator that I just circled, let me do it in blue. That denominator that I circled in blue, because I was thinking about you, is it needs to be factored, right? So factor it. So it'd be x times x. And then the 49 breaks apart into negative 7 times positive 7. There we go. That also has the x plus 7 in it from the other side too, right? So that itself, those two things, those are the least common multiples of the denominators. So let me rewrite this. 3x over that, and then minus 5 over that, and nothing else, right? Now here's the issue though. If you have an equation, you can clear the fractions from the equation by putting the LCM of the denominators, by putting the x minus 7 and the x plus 7, you can put that beside, so I'm writing it down temporarily. You can put that beside everything on both sides of the equation, and then you can clear out the denominators. Except though, as wonderful as that is, that doesn't work in this problem. Do you know why not? Because there's no equal sign with like something on the other side, like there's no 0 or anything else. So in math, you have to have like equality in math. You can only do something if you do the same thing to both sides. So even though it did the same thing to both fractions, these two fractions are actually only on one side. There isn't another side. So I haven't done anything to this other side yet. So this is mathematically not actually allowed. So unfortunately, I can't actually clear the fractions unless it's an equation, which is really sad. So this is when I actually do have to get a common denominator. So I can't actually do that. Instead, I'm actually literally going to have, so I can't get rid of the fractions actually. I have to actually make the fractions have a common denominator now. So this denominator already is the common denominator, but this one's not. So what do I need to multiply by to get that denominator to be a common denominator with the other denominator? Well, I just have to multiply by what it's missing that the other one has. So like imagine that this is your neighbor, the Jones, and this is your house, and the Jones got like a new sprinkler. So then you wanted your house to have a new sprinkler too, so that you could be just as good as the Joneses. Have you ever heard of that type of scenario? So we just need to add in that new sprinkler to the bottom of the fraction. Now that you still have to follow the rule that what you do to one side, you do to the other side. However, though, as long as you're just doing it to one fraction, then you can make it fair by, if you add it into the bottom side, then you can add it into the top side, beside the top side and beside the bottom side. So there we go. So we multiply the bottom side and the top side by that, which is fair because you're doing it to both sides. So you can, the rule is you can multiply both sides of an equation by something, or you can multiply both sides of a fraction by something. Does that make sense? But if we don't have an equation though, we can't just multiply both sides of the equation by something because we don't have an equation. Does that make sense? So anyway, in equations, you can get rid of fractions completely, but if you don't have equations, you actually can only get a common denominator. So now they do have a common denominator, right? So let's join them all together. So this is kind of like the United States joining all together. And the denominator is kind of like the constitution of it. So both of those fractions have now agreed to have that one common denominator for their constitution or whatever. And then on top, you have the 3x that comes together onto the top of that same fraction. And you also have the negative 5 times that x, which is negative 5x. Then you have the negative 5 times the negative 7, which is positive 35. Then you get 3x take away 5x, which is negative 2x. Negative 2x. Plus 35, which is incredible because we were talking about the United States. And the age to become president in the United States is 35. So any of you planning on running for president when you're 35? So there's that. So negative 2x plus 35 over, ooh, I left something out. I made an embarrassing mistake. Does anybody see what I left out? Yeah. So that math, that would be like having a title in your English paper with like a missing word or something like that. So negative 2x plus 35 over that. So that's it. So we're done with that problem. Wonderful. Now let's do number 11. We only have 3 more. Did you realize after these 3 problems, we're just going to be reviewing for the final? It's hard to believe that we're that close to the end. So, number 11. Number 11 says factor any perfect square trinomials. So 81x squared minus 18x plus 1. So remember the perfect square factoring method. It was actually one of the silliest factoring methods because what you do is you don't know for sure if the answer is right until after you've tried it. So how do you do the perfect factoring method, the perfect square factoring method? What you try to do is to take the square root of this term, which would be 9x, and then you try to take that sign, which is still minus, and then you try to take the square root of the last term, which the square root of 1 is still 1. And then you put a perfect square outside of it. So it's not really actually a scientific method necessarily. It's just kind of like have you ever heard of the word heuristic method? There's just like a process to it, but it's not really necessarily based on any type of guarantee. So this is not guaranteed to be right. But when you do a heuristic method though, you have to have a way of knowing if it actually did turn out right or not. So how do we know if this actually did turn out right, or if we need to redo it and try another way of doing it? The way to know if it did turn out right is by checking, because, okay, number one, you know for sure that if you took this 2 and you squared this, you would get that, right? If you took this 2 and squared the negative 1, you would get the positive 1. So that part of it's guaranteed to be correct. The only part that can be wrong is the middle part. So, which sounds like a hairstyle, like a middle part. So how do I, whoops, sorry, wrong thing. How do I check to see if it's actually correct? Well, remember when you're squaring a group of 2 things, always when you square a group of 2 things, the shortcut is to bring the 2 down and multiply it by that term, which will give you negative 2. Then multiply that negative 2 by the 9x, which would give you negative 18x, right? And if that does actually match up with the original problem, so is negative 18x equal to what was in the original problem or not? Yes, it is, because the original one did have negative 18x. So that verifies that it did work. So this is the correct solution. So this is the one problem on the test that I'm going to let you sneak by without showing more than one step, except I do want you to draw this arrow to show that, to prove to me that you really did think about bringing that 2 down from this, then multiplying by this, to prove that it equaled the middle number. In fact, why don't you circle the middle number too, like that? Because it's so easy that there's not really any work that you can even show. You basically just do it. And then you check your answer mentally by bringing that 2 down, multiplying it by that and by that. And then that verifies that it does equal the middle number. So how does that sound? So this problem could be the fastest problem on the whole test. So let's do number 12. So number 12 could be the worst problem on the whole test. So we went from good to bad in a flash. My dad always used to say, when he went into a store, he'd say, "I'll be back in a flash with a little less cash." Have you ever heard anyone say that before? So then he'd come back with a little less cash with something that he bought. So 12. So problem number 12, it says 35 a to the 2b plus 285 ab whoa, minus 270b. So the question is to be or not to be. That is the question. You ever heard that quote from Shakespeare? It was Shakespeare's birthday like last week, I think. 599th birthday or something like that. I'm not sure how much actually. But we have to, in order to make this problem be easier with all those b's in it, we have to factor out a b. Is there any, because there's a b in common, right? Is there any other number that's in common to all three of those terms? I'll give you a hint. Notice that all three of the terms end with a 5 or a 0. So any number that ends with a 5 or a 0 is divisible by 5, right? So 5 would be divisible outable. Well, it's divisible into them. It's also divisible out of them. So let's divide a 5 out of all three of those things, and let's also factor out a b from all three things. So if we divide 35 by 5, that'll leave us with 7, a to the 2. So you know the a2 is actually kind of music. So 7, a to the 2, b. Oh, the b is gone. And then what do you get if you divide 285 by 5? Should I give you a hint? Did you know that if you divide by 5, you can actually think of it like this? What would you get if you divided 285 by 10? You get 28.5, right? Now double that, you get 57, right? You get 57. Whenever you divide something by 10 and double it, that's the same as if you divided it by 5. So that's a shortcut. So you get 57a minus, and then let's do the same trick on this. If you divided 270 by 10, you get 27. Then double 27, you get 54. So that's 54. So, and the b is already factored out. So I made the problem b easier by taking out a b. So 5b parentheses 7a squared minus 57a minus 54. Now I've converted it into the rainbow type of problem. Remember, where you have to drop the square off of the 7a squared. So just write 7a and 7a. By the way, you know what would be great? Is if each of you can get 7 grades of A in your classes this semester. That would be sweet. So 5b in front, 7a and 7a. Then bring down this sign, plus, and then this is where the first rainbow happens. Draw an arrow from here to here. Plus times minus is what? Plus times minus is minus. And then draw a rainbow from that number to that number. 7 times 54 is what? Well, that's a huge number. 378, I think. Is that right? It's huge. 378. And then are these numbers different from each other, or are they the same as each other? The signs. Different or the same? Different. So if those are different, then I need to find 2 factors of 378 whose difference is equal to the middle number in the original problem, which is 57. So how do I find two numbers that come from 378 whose difference is 57? Well, that's really a struggle. So you know what I'm going to teach you the secret trick of advanced mathematics. It's not really advanced mathematics, but a secret trick of our class. So what we did is we multiplied 7 times 54, right? To get 378. Well, let's just take it back to 7 times 54, and then let's take it back even farther. So does 54 break apart into anything or not? 9 and 6, exactly. So let's break it apart into 9 and 6. And then does 9 and 6 break apart? Yeah, 3 and 3 and 2 and 3, right? So 3 and 3 and 2 and 3. Did you realize what I've actually just done makes it a lot easier to think of 2 pairs of numbers? So I could draw a little balloon like around those 2 numbers and make that one number. I could draw another balloon around that set of numbers and make that the other number. So what is 2 times 3? That's 6, right? And then what is 7 times 3 times 3? That is 56 times 7, 42, right? Now I need a number whose pair of numbers whose difference is 57. There's a difference between 42. Oh no, that's not right. That's 9 times 7. My fault. Just kidding. So that didn't work because I made a mistake. But 7 times 3 times 3 is really 7 times 9. What's 7 times 9? 7 times 9 is 63, right? And this one is 6. And is the difference between 63 and 6, is that equal to 57? Yes. Now, I actually didn't expect it to work on my very first guess. What I was going to do is put a couple of balloons around them to divide them into 2 sets of numbers. And then I was going to try to put another balloon, like this balloon and these 3 numbers. So when you break the numbers apart, you can put a little balloon around like a group of them and another group of them, as many ways as you can think of, until you get a pair of numbers. Each balloon represents one number of the pair. So this time when I put them like that, one number turned out to be 63, the other one turned out to be 6. And it was just a complete coincidence that I happened to get the right answer on my first try. Because the difference between 63 and 6 already is 57. So that's 57. And that's, now remember, you always put the biggest one first. So that's not 57, sorry, my fault. I'm really making mistakes today. That's supposed to be 63, right? And then that's supposed to be 6, because the difference between 63 and 6 is 57, right? So I found that. Now I'm still not quite done with it yet. So right now you've gotten all the way, let's say you're trying to get graduate from college. Right now you've gotten all the way up to the stage, and then you're nervous. So did you know that if you get to the stage and you're too nervous to walk across the stage, that you won't get your diploma? Just kidding. I'm just kidding. So right now we're almost to the step of having graduated from this problem, but we don't have the correct answer yet. We haven't gotten their diploma yet. So what do we have to do to finish it and make it be correct? What's the last step after these first 2 steps of factoring? Well, remember, when you factor out like this, you drop the square, but you really can't keep the 7 in both places, right? Because 7 times 7 equals 49, which is not 7. So part of those 7s is wrong. And how do you know which one is how much wrong is it? Well, whatever number divides into either one of those parentheses, that's the wrong amount. You have to divide by that much to get rid of the wrong amount. So does anything go divide into 7 and 6? No. Does anything divide both into 63 and 7? Yes, 7 goes into both. So that's the wrong amount that we have to get rid of that. So 7 and 63 are the right numbers, but in those right numbers, they have the wrong number, which is 7. So then now it becomes A plus, what's 63 divided by 7? 9. So this is the correct miracle answer. That we should call this problem the miracle problem, because this was, well, it wasn't that hard except for it started with big numbers. So we had to factor 5 out of all those big numbers and a B out of all those big numbers. It was really actually pretty tough though. So you know what I'll be really impressed by? It'll make me think of you as shining stars if you can finish problem, which I don't know which number it's going to be. But if you can finish this problem on the test and get this one right by knowing all those steps, it'll be so good. There we go. Guess what the person who sewed dresses always would say about things that she liked? She would say, that's so good, because she likes to sew. Let's look at the last but not least problem, and then we're going to be done about 30 minutes early, hopefully. Oh no, well, I'm sorry, actually this problem is a little tough. So did one of you say you'd have to leave 30 minutes early, right? Because it actually is about 30 minutes from the end of normal class right now. So if you have to go, you can go. But okay, so this one says, I erased part A, that was useless, but I'm just going to do part B. But in part B, there's really two parts. So since there were already two parts to part B, I decided to just make it only be part B. So part B says f of a plus h minus f of a. But in order to do that, you first have to do f of a plus h. So what that means is you just take the x squared and the minus 7x and the plus 3, and everywhere that you had previously had an x, you would have an a plus h instead, like that. Do you see that? So take your formula for your function, plug in a plus h, that's called f of a plus h. And then we're going to use that shortcut that we learned about when you square a group of two letters like a plus h. Then you square the first one, and then you bring the 2 down and you distribute it times the a, h, and then you move that h times 2 times the a. So 2ha, or 2, actually, let me say 2ah, actually. It doesn't really matter, but no, actually, you know what? Well, never mind. If you multiplied it out the long way, which I was thinking about doing, you'd actually get a times h first, and then you get h times a, which would spell aha. So I was going to say aha when I got to that point. But if you do the shortcut, you'll actually just get 2 times h times a. So it's like 2 ha, but it's not ha ha. So a squared plus 2ha. And then I apply the square to the last term, the h. So it's h squared. A squared plus 2ha plus h squared. So then I distribute the negative 7. So it's negative 7a and then negative 7h. Then I just bring down the 3. So right now I'm finished with f of a plus h. So I'm going to draw a box around that. That's part A. Then part B of part B. Well, this whole thing is part B, but this is part A of part B though. Then part B of part B is to find f of a. So f of a is the formula x squared minus 7x plus 3. So it's the same function, except instead of x squared minus 7x plus 3, you have to plug in a for x. So that's just, so f of a just equals a squared minus 7a plus 3. So do you all have that figured out? Now, the very last step in this last problem of our last question on this review for the test is we have to calculate what this is. What is this? What is f of a plus h take away f of a? That's what it says, right? On your paper, it says that, right? Find f of a plus h minus f of a. So what we have to do is we have to take f of a plus h, we have to take this blue box, we have to take that blue box, and then we have to subtract the black box, right? So we have to take f of a plus h, which theoretically represents all of this, and then we have to subtract all of this. So it's really important to understand how this works. You're basically, when they say f of a plus h minus f of a, they're really wanting you to take two math problems, the f of a plus h math problem, that answer, and then the other math problem, which is a squared minus 7a plus 3, that one. Then you subtract those two math problems from each other to get the final result. Does that make sense? Can you do that? So what happens if I do, so let me write this down. Hold on just a second. So f of a plus h minus f of a would equal everything that's here minus everything that's here. So if you did a squared minus a squared, you'll get nothing, right? So that one is nothing. Then you'll have 2ha, but there is no ha in that one. So that one is going to stay. So then you'll have h squared, but there's no h squared, and then so that one will stay. That's plus h squared. And then you'll have a negative 7a minus a negative 7a. But if you minus a negative 7a, that's really plus 7a. So you have negative 7a plus 7a, which is nothing. You won't have anything for that term. Then you'll have a negative 7h minus, well, there's no h in this one, so that'll stay there. So it'll be negative 7h minus nothing is just negative 7h. Then you have 3 minus 3. What is 3 minus 3? It's nothing, right? So the answer is this. And I'll give you a secret. Every time you subtract f of a plus h minus f of a, the only things that will still be there are the ones that have an h in it. Because the only thing that you have in this one that isn't in this one is the things that have h, that have the letter h. So everything that doesn't have the letter h, like the 3 and the a and the a squared, those will all subtract away and be gone. Thank you for saying. See you later. What? Yeah, that's the last thing actually. So this is the end. So do you feel prepared for the test on Tuesday? And by the way, you can write, just like I said on the first 10 class test, you can take one 8.5 by 11 piece of paper, like just like this size. It has to be blank at first, and you can study for the test and write. It has to be written in your own handwriting. It can't be like printed out from any type of website or anything else like that. Can't have any of these, like you can't print out these problems or anything. Whatever you want to study and write in your own handwriting, you can write that as much as you want on that piece of paper, and you can bring it like it. Yeah, it could be like that, but it just has to be your own handwriting. It can't be printed or anything. Whatever you want to write in your own handwriting, because I want you to be studying for it. So whatever you write down like represents what you studied for it. So it can't be something that you didn't do, like just printed something out. It has to be stuff that you wrote down. So you can write as much as you want to on it, and both front and back if you want to, or just one side, whatever you want. But you can use one whole page for writing whatever you want to in your own handwriting and bring that with you and use it on the test. So see you later.